I'm Abby Cooney.
And I'm Ezra Hess.
And I'm Colton Martin.
Okay. And we've just been assigned to construct a marble sorter.
Our constraints are that our device must be able to receive 30 unsorted balls at once. It must automatically sort the marbles into 3 bins according to their color. The device must sort at least 15 balls per minute. We have a $50 budget to spend on sensors and actuators, and the framework should primarily be built out of 1/4-inch plywood.
The materials we have for this project are bolts, wires, circuit boards, servo motors, Arduino boards, 3D printed parts, laser cut plywood, anything we had access to previously in the course, and we also have the $50 budget for sensors and actuators online.
We actually have 3 ideas so far. One of them I was thinking about that I like is we have like a revolving door here where the marble goes in and gets sorted out and sensed.
This design involves 2 ramps and 2 servo motors, 1 servo motor to release the marbles and 1 to deflect them into the different boxes.
Here was our other idea. We had like a 1/4 of a circle that would spin and pick up a marble every so often, drop it down a hole, and then down to a servo that has a ramp on it to each of 3 boxes. We ended up going with this design because it prevents jamming, because the balls can actually sit inside the disc, and it's also more efficient because it releases a ball and picks up a ball at the same time, allowing for more balls read. Here's our design concept in cardboard, and then we have here the ball going down the ramp on either side, not shown there, but it will be, and then we have servo motor on the bottom which can go in any direction, which allows for more adjustability.
We didn't choose our other ideas because they were bulkier, using more space, they were less efficient, they use more servo motors, and they have a higher likelihood of jamming.
Here's us on SolidWorks designing the laser cut parts and the 3D printer parts, and we're figuring out dimensions from the servo motors, how it's going to fit together.
And here's me assembling everything for the first time after the wooden pieces were laser cut. And then here's the full assembly.
Here's us assembling the final pieces like the servo motors, gluing it all together, the color sensor, and finally screwing all the servo motors in.
So here's us calibrating the top servo motor. The angle was a bit off and it was rotating too far, so we fixed that and also made the bottom servo rotate to the right bin for each color.
We were having issues with the color sensor accurately reading the colors of the marbles, so we adjusted the height of the tube to adjust the height of the color sensor as well.
After getting all the individual parts working, here is our first full test, and as you can see it works pretty well, but there's still a lot of adjustments we want to make and changes for efficiency and reliability.
Here we are fixing some minor mistakes we had in the SolidWorks files and fixing them to fit together.
Our main issue was the marbles jamming, so we designed this funnel system. The top compartment has a servo motor which releases a few marbles at a time into another angled compartment and then finally into the tube and onto the rotating disc.
Here's us redesigning the 3D parts. The ramp was not tall enough in the back, so we had to redesign that. And then the 1/4 circle, the holes weren't quite in the right space and it tended to bend.
We've decided to try to put the color sensor inside of the tube instead of using the IR sensors on either side of the tube, because then we can still use both sides of the revolving disc.
Here we are soldering the components to a circuit, and then we finalized everything by implementing all the designs changes we just showed you, and we put walls on the ramps to make sure that the marbles don't fall out, and we made the chute go a little bit lower and just installed the new 3D parts to make everything fit together nice and finalized our product. So here's the final test before the demonstration. We had it sorting red into the left, green into the center, and blue into the right bin, and it was working pretty well, and we were satisfied and felt confident going into the demonstration.
The final design is a lot more efficient than the initial one because we changed the coating so that the marble will be a lot more efficient as they're going through the pathways, but not so fast that they get flung all over the place. And so our design is a lot faster and it is also more accurate.
In the final demonstration, we sorted 30 marbles in under a minute and had 100% accuracy. Okay, overall, we're happy with the results of the final demonstration. We had 100% accuracy, and actually our sorter went at double the required speed, but here are a few things that we would change.
We probably make the boxes a little bit closer together and shift them back a little bit so it could make it even faster, and we redesigned the box so that the 1/4 circle would not have to rotate as far.
And we redesigned the 1/4 circle itself to make it a little smaller so that it can move faster, move more distance, and then we make a housing for the sensor so it's a lot more stable and can make more accurate readings.